Hello, welcome to the RIBA Northeast Sustainable Futures Forum. As you know, today we're going to be looking at embodied carbon calculation processes, different tools, 5 different tools in 50 minutes. Yeah, it'll be coming at you quite quickly, and just waiting for a moment or two while people file in and everyone gets their digital connections up and running. And then we'll get into a little bit of context before we start to hear from the speakers that we're hearing from this morning, or this early afternoon. Obviously, this particular event today is following on from our embodied carbon calculating embodied carbon in structures event that was run the other month. And of course, it's in that broader context when we start to think about climate change and the likely impacts that we're having. I'm not going to go over this graph in any great detail, but basically we've got a range of different scenarios that need to be thought about, and of course embodied carbon is a part of that. Those considerations. I'm not really going to dwell on the context for what we're talking about here insofar as embodied carbon versus energy and use, etc. But suffice to say that in the context of the RIBA, we're focusing really on the RIBA 2030 challenge and the trajectories there, and really we want to be focusing on trying to certainly keep to the programme, if nothing else, in terms of looking at the 2025 targets and 2030 targets, and making sure that we hit those targets, and that's obviously going to have some distinct impact upon how we practice and how we think about design. In terms of the RIBA 2030 challenge here, then basically for domestic and for non-domestic buildings, we're focusing on that chunk that's in the middle, which I've bracketed off, which is our embodied carbon. So these tools that we're talking about today are basically going to help you design your buildings so that we can get to the RIBA 2030 target there of in the target threshold of around about 300 kilograms of carbon dioxide equivalent per metre square of the property for domestic, and up to 500 or less than 500, I should say, for non-domestic. Now that obviously introduces a whole host of different challenges, and I know that there's some ongoing work reviewing these targets and streamlining them, shall we say, to make sure that they work in the most appropriate fashion. But this is the best information that we've got right now. Interestingly, I worked on a project, Larch Corner, and we calculated the upfront carbon, the embodied carbon, and that was coming in at 421 or 422 kilograms of carbon dioxide, and whilst it sequestered a similar sort of quantity there, but that puts us very much into that 2025 target, even though everything above the ground was timber. So but that does include the renewables that are involved as well. So there's quite a lot to dig into there. And in terms of context, if you're working on any public works projects, then basically embodied carbon calculations are kind of bound into the construction playbook now, and therefore that's something that will need to be considered going forwards on public works. Some of the challenges relate to tying in with European standards, as it were, and also assessing quantities in an appropriate way, getting hold of information about environmental performance declarations, which obviously fit into embodied carbon calculations, and obviously tying in with RIBA, CIBSE and iStruct-T different requirements. So as I say, this is a whistle-stop tour, 5 embodied carbon calculators in 50 minutes, plus some Q&A afterwards. If you can stay on for a little bit more than the hour, then you'll get more from the Q&A process. The running order for this morning, we're going to hear from Penny Gowler from ElliotWood, talking about the structural carbon tool. We've got Jack Williams from FCBS talking about the FCBS carbon tool. We've got James Todd from Architype talking about the Ecolab tool. Jake Attwood-Harris from Hawkins Brown talking about Herbert or HBERT, and we've got Tim Martel talking about PHribbon. Okay, that is it. I'm not going to add any more context or any more information to this. It's now over to Penny, who will be able to tell us all about the structural carbon tool.
Thank you, Mark. All right, okay, thank you. Let's get started. So, hi everyone, a bit about me and ElliotWood first. I'm an Associate Director at ElliotWood and I head up the sustainability across the company. I was heavily involved in the development of the structural carbon tool that I'm talking about today. ElliotWood, we're a friendly bunch of structural and civil engineering professionals with a very strong desire to do the right thing and engineer better wherever we can. So at ElliotWood, we developed an embodied carbon tool 5 years ago to allow us to quantify embodied carbon in the structures we design, and most importantly, help us make better decisions. It's now an integral part of our design process on all of the projects we work on. The leaderboard that you can see here followed the tool, and it allows us to have some friendly competition within the company, celebrate successes and constantly share knowledge about ways we can further reduce embodied carbon in our designs. So in late 2020, we approached the Institution of Structural Engineers and offered to update our carbon tool to align with their recently published guidance, how to calculate embodied carbon, and then donate the tool to the industry for free. So the tool was launched on the 18th of March last month, and it can be downloaded by anyone who wishes from the institution's website. So before I run through the tool in detail, just wanted to recap carbon lifecycle modules and explain that our tool currently covers modules A to C, but it doesn't currently include in use module B. Largely because the tool is aimed at structures and the structure doesn't have a huge impact on in-use module B. So we can talk about whole life carbon A to C by excluding B, upfront carbon A1 to A5, and we also report module D separately. So moving on to the tool itself, before launching into a live demo, I'll talk through the key features of the tool first. So starting with this page, which is the scheme input page, it's just an Excel spreadsheet, and this is where you can enter the material specifications and quantities to estimate the embodied carbon for a scheme. So the tabs at the bottom highlighted here indicate all the sheets that are available to you. The intention is for you to work from left to right. Orange tabs are information or basic project information to enter. Blue tabs are scheme input pages like this one, and the green comparison sheet covers the main output from the tool. And then the grey tabs are for advanced users, so you don't have to go there if you don't want to. So at the top, you can see you can enter your scheme name in that top box there, and the tab for the sheet will automatically update. You can then use the drop downs in this area highlighted in red to enter material specifications, specify the type of elements, and these are aligned to the RICS rules of measurement. You can then specify your quantity in either mass or volume, although volume is preferred, so it uses the inbuilt material densities. And then the quantities themselves, you need to calculate outside the tool. So you can either do that by hand, using an analysis model that you might have, or a 3D BIM model such as Revit. But it's quite flexible in that respect. For concrete, you can specify reinforcement based on inbuilt standardized values, or you can enter it as a separate row if you've got more detailed information. So once you've entered these quantities, the spreadsheet automatically calculates the embodied carbon for each row. So it separates the carbon by the life cycle stages that we've just discussed. Then onto the results below. The box in the middle summarises the total embodied carbon by upfront carbon and whole life carbon with sequestration and module D reported separately. So that's just a summary table. It also gives you figures of kilograms of carbon per square metre. And then the bottom half of the page provides summary charts and information for that scheme. And this can be copied and pasted into reports or emails. The pie chart gives you a breakdown by structural element, so you can hone in on areas of the building that may need to be refined. The central section provides some tangible metrics, which can give some context as to what 1,000 tonnes of carbon might mean, which is really helpful when talking to clients. And then we've also compared the embodied carbon against industry targets, including SCORES, the RIBA target, SCORES, which is an Institution of Structural Engineers labelling system, as per the right here, RIBA, which you'll be familiar with, and the LETI targets. So just to note, you can enter up to 6 different schemes into the tool, which we've always found to be more than ample. So once the structural schemes are entered, there's a separate scheme comparison page where various charts are populated for you. These can be used in reports or emails as you wish. I won't go through those in detail now due to a bit of lack of time. Also included as part of the comparisons page is a simplified graph of the carbon in the atmosphere as a result of construction over time. So for a non-timber scheme like a steel or a concrete frame, there's a big jump during construction for module A, then it's horizontal during the life of the structure, module B, because we're not including module B currently. It then jumps up again when the building is demolished or preferably deconstructed, which is module C. For timber schemes, we followed a forward-looking approach because we're thinking about carbon in the atmosphere on the y-axis. So we start with 0 when we start construction. Modules A and C are represented as jumps upwards again, but in between these, the line dips down to represent the sequestration from the replacement trees in your sustainably sourced forest. It takes 50 years to realise the sequestration. So the scheme input pages and the comparison charts that I've just shown you are basically the only part of the tool you need to be able to use to get data out. However, for advanced users amongst you, we've provided a number of options for modification of the base data. So all the base data is included in a single table, and you can amend data values directly into that table, and it highlights where changes have been made. If you make a mistake, you can reset by hitting the reset table button, as there. So this facility can be used to modify carbon factors for materials sourced from different countries, for instance. The next table that you can modify is you can add your own materials via the custom EPD table. So if you wanted to use the tool for architectural materials, this is where you would add them, or it's the easiest place to add them. And then finally, to help with making amendments to this base data incorporating site-specific EPDs, we've included some calculators for the calculation of A4, transportation, lifecycle stage C2 and timber end of life. You can also specify reinforcement densities in the custom reinforcement table, and buttons are provided to allow you to reset to default values or switch between end of life scenarios. So on to a very quick live demonstration now. So as I explained, the first two orange tabs are just information about the tool, what its purpose is, how to use it. Project info page is the first tab where you actually have to enter information, basic project information here. You can select a typology. These are only used for the comparison with targets, so there's only a few typologies, so pick the one that's closest. Project value is important, so it's the whole building construction value, and that's required for the A5A calculation. And then the gross internal floor area is also needed to calculate carbon per square metre, and also for the C1 calculation. This table at the bottom here are assumptions which you can change if you wish, but otherwise just leave them as they are. So then we go on to the scheme input page. If I just zoom in quickly, it's really simple. You can go into material, select which material you're after. So let's do concrete, for instance. Say in situ. It's got a series of different concrete mixes in here. If you wanted to add your own, you could add it through the custom EPD that I showed you earlier. Say these are roof beams, for instance. Just write beams. You can give a volume, it's easier for concrete normally. And then it will highlight you that you need to put some assumptions about reinforcement in, so general beam, for instance. And then just on the right hand side here, it just automatically calculates all your carbon values. If we zoom back out again, you can see the charts here don't make much sense because I've just added random information. But scheme 2, for instance, is a proper real life RC frame scheme. And you can start to see the value of the charts here. You can see the breakdown by the different types of elements and all of the target information here. So you can do that for up to 6 schemes. Then you can switch to the scheme comparison page, and here you can select which schemes you want to compare. So we don't want to compare that first one because it's just rubbish data. You can just hit update charts and it will update those charts for you, and you can then use those in reports or however you want to. And then the cumulative embodied carbon over time chart is shown below. The grey ones are the advanced options.
Okay.
Am I running out of time? Sorry.
Yep, we're on 10 minutes.
Okay. just very, very quickly, the tool's designed to focus on structure, but there's no reason why architectural materials cannot be added, and we'd be more than happy to discuss opportunities for doing that. It's about calculating carbon, and it's not about calculating carbon, it's about reducing carbon, and please download it from the link, and it's there to be used. Thank you.
Thank you very much, Penny, for the whirlwind tour there. Okay, so our next presenter is Joe Jack Williams from FCBS.
If I unmute, hi there. Yeah, excellent work getting through quite a lot of work in 10 minutes, so pressure's on. So I'm Joe Jack Williams, I'm an associate from Feilden, Clegg, PHribbon. I'm going to talk about FCBS Carbon really quickly. I presume you can all hear me. It's still saying, telling me to unmute my mic, but I'm just going to ignore that because I can see Mark nodding. Thank you, Mark. This is our route to zero carbon as a practice. It's pretty go-y. By 2025, all buildings starting on site will be net zero carbon. We will ignore the fact that net zero carbon is an ambiguous term and it kind of all makes us nervous, but it's certainly the thing that keeps me up at night. I look after the kind of sustainability and research across the practice, so it kind of falls on my shoulders in many ways. Although obviously it's collective responsibility, but still at the same thing, there'll be a lot of pointing. So as I kind of look at this for FCB, this is the scale of FCB. This is the number of projects on the left. Truly terrifying number of projects. But if we're trying to hit zero carbon by 2025 on site, really we need to be thinking about how we can make those zero carbon decisions really well at the start of a project. This is where we can make low-cost decisions that will have a significant impact. Really, as we're starting to think about massing, number of stories, net to gross, all that kind of fun stuff, materiality, how can we make those kind of decisions? And so we're looking at kind of stages 0 to 2. Stage 5, nobody's going to thank me if I turn up and tell the contractor that they're going to change the framing system on their building. I think pretty much everybody's going to hang me out to dry, or at least just shout at me, and quite rightly. So this is where we're really looking at stages 0 to 2, and this is where, as an architectural practice, we're probably a bit more alone. Maybe we don't have an engineering support sort of system with us, where we don't have sustainability consultants. Maybe it's us and the client. It's trying to get those kind of ideas across, and this is really where FCBS Carbon's born out of. And you can quickly imagine that if we just had 2 design iterations, and of course we've got far more massing than just 2, we can have 108 design iterations very, very quickly, and every single one is not necessarily a clear-cut decision-making process. Every single one could be swings and roundabouts. Is it better to use a thin amount of brick with more steel framing system, or is it better to have more brick and less steel? All these kind of things, it's not necessarily clear. So this is where we set out with FCBS Carbon. Now the problem is, at an early stage, you really need a bill of materials and you really need embodied carbon quantities. And that's all you really need to do, embodied carbon. You just need those 2 things, but getting those 2 sets of numbers together is really very difficult at an early stage. So what we did is we made loads of standard construction build-ups. We've got a long history as a practice. We just went through, started pulling together typical materials that we're building from, steel framing systems, brick and block, or whatever else, cassette panels. And then we have an algorithmically designed building. So it's not a real building, but it is kind of consistent. It's kind of about right. And it's this idea of, we're able to record what our buildings are doing from a very early stage. So, Penny had a really nice shot of ElliotWood where they were ranking all their buildings together, which I love a bit of competition, but also enables us to estimate it. And it doesn't have to be perfect, but it gives us an estimation. It's a kind of start point. Stage 1 to stage 2. We don't know who's going to supply stuff. And it's all about, how do we understand where the carbon's going? Is it facades? Is it glazing? Is it roofing? Is it the membranes? Is it the door handles? We just don't know at this kind of stage. Having that kind of discussion with a client is really useful. So really early stages. It's based in Excel because everybody has Excel, like it or not. It's pretty straightforward to get in. You don't need to have anything, any kind of complex systems. You can do it with a model you draw up by hand and just input the data in. but it's all about direction and magnitude. You make a change, does it go up, does it go down, is it loads up, is it loads down? If it's not loads, it might not make a difference in practical terms. So just really about exploration, but really getting to understand how our buildings use it. You know, we've got 200-ish people in FCB. I need all of them to understand that every time they make a decision, there's a kind of impact. You know, does it go up, does it go down, and get that kind of iterative design process. You know, we often think of it being linear, but it's really not. It's about going out wide and then coming back in. So I'll just quickly show you how it works. So this is our whole life carbon model. Penny showed a different version of the graphic, which is probably slightly more accurate, to be honest, but this is kind of easier to read, I think. But we, in effect, estimate A1 to A3 pretty robustly. We use the ICE database. We take data from there, standard build-ups, and that's all the way, you know, cradle to gate, if you like. And then we estimate all the rest of it using percentage uplift based on the Letty embodied carbon primer and the RICS guides. So it's kind of fine. It's internally consistent, and that's the thing. But bear in mind, it could go up, it could go down. You know, it's like a financial investment. And it's in Excel, so there's a bit of sort of simplicity to it. So there's 3 input pages, which are yellow. There's 2 output pages, which are in blue. All the way through, yellow is an input, blue, sort of dark blue, grey is a sort of calculated bit. Hopefully it's colorblind friendly. I think it mostly is. And you just work your way through it. Like all good spreadsheets, you start at the left and work from left to right. Input all this, import all this is super important. If you don't put in the year of completion, it will come up with errors. It is doing clever things in the background about it's modeling 100 years of your building. We've only got a few limited typologies. We've got housing and offices. Both are kind of fine. If it's domestic, use housing. If it's non-domestic, use offices. It won't make a huge difference currently, but it will just help you with kind of RIBA targeting. Do fill in what your objectives are. It's really nice to have this sort of thing. If you have to come back to an award, it's nice to have it written down somewhere for a start as well. Write it as you're thinking about it. So this is your operational energy input. Currently, it's very basic. You just have to make an estimate. If you're all working to RIBA 2030 challenges, you can just put in 35 or 55 kilowatt hours. If you've got great engineers, they might give you some better figures here. There is benchmarks here. It's probably too small to read on your screen, but it will give you a bit of guidance of what current industry practice is. And if you download it, there's a bit of guide. It tells you, it can help you with sort of power generation, these kind of things. Anyway, you can pop all that in, nice straightforward. This is the real kind of meat of it, if you like. This is our embodied carbon sheet. In here are the 7 inputs that you're required to put in to generate a whole building. And then once you put those in, they're very simple. It's perimeter, it's footprint, it's average building width, building height on average, you know, all these kind of bits and pieces, numbers of stories, simple stuff. If you don't know it, guess it, build your building up and then change it. You know, it's really easy. It's just one figure to change. And then down here, we've got building aspects, and you can add more, you can add less, and it just guides you through it. And it's a kind of collated, curated set of data, if you like. So you can pick a kind of foundation material, you can pick a floor type, you can pick wall types, glazing types, and it'll guide you all the way through it. And you can start to say whether it's new or existing. You can start to say, use this adjustment factor to make it a bit more appropriate for yours. You can put component lives in and say whether it's designed for disassembly. And I'm rapidly running out of time, but these are the kind of outputs. I can see Mark nodding. This is your main output. It breaks down, so it's per building element. It tells you what's emitted, what's sequestered, how you're doing against the 2030 challenge. What's your carbon doing, your operational versus embodied over 30, 60, 90, 120 years. Here you've got a bit about trees, how many trees it would take to offset it. It's always nice thinking hectares of forest. I like a forest. The more we can build, the better. And then there's a bit more of a detailed output here, a bit like Penny was showing from the extra T tool. You know, what goes on with it. Bits of breakdowns per life cycle assessment bit, and you know, some kind of nice figures here. So loads and loads of data you can get out of it very quickly, and it takes me about half an hour to build up a building, and usually I do it kind of live online, but oof, yeah, 10 minutes is probably a bit tight even for me. But there you go. So you can download it for free there. It's free, play around with it. Don't, you know, it's in beta testing. Let me know what you think. I'd love to hear what you all think about it. So there you go, smashing.
Wonderful. Well, another whistle-stop tour. Thank you very much. Now we'll go over to James Todd. James, take it away.
Hi, hopefully you can hear me okay. So I'm Associate Director Architype Architects, and I've also been involved with developing an embodied carbon tool for a number of years now at Architype. A little bit about Architype. We're kind of pretty well known in the industry for our kind of expertise in passive house, and in-house as well. We're kind of very interested in building physics, which has kind of grown out of our passive house work. And we do kind of look at kind of POE and carbon consultancy as well. In terms of the tool Ecolab that we're developing, it's very much a kind of collaboration. So it's Architype working with Chapman BDSB in terms of services, Curry and Brown in terms of cost, and Greenspace Live in terms of software. So I guess picking up what Joe was saying, we're very interested in this idea of kind of this very early stage of a project and the influence it has on the overall project, and particularly the decisions that people are making at those early stages, how they bake in impact over time. And we're very frustrated about this sort of sense of looking at things in isolation. So for example, so this is kind of opening things out a bit wider than carbon, looking at carbon isolation of cost and isolation of energy, and how actually we ought to be able to visualize all of these things together in one space, which was the kind of inspiration for developing Ecolab. So typically, as Joe was saying, you know, there's a real opportunity early on to make big differences, and as the project progresses, as we know, it gets harder and harder to make change, and a lot of those decisions are kind of baked in and the impact's baked in. So at the heart of Ecolab was this concept of being able to model really rapidly energy, cost and carbon right at the outset of the project. So by bringing these three things together into one space, it enables us to kind of avoid these kind of perverse outcomes where we might invest a lot of input into one aspect, but then create a big impact somewhere else. Another frustration that we had as architects was this sense of everything working in silos. So we're very interested in how could we develop a tool that would enable us to actually bring everything into one space. So everybody could kind of look at this model, interrogate it, clients, contractors, consultants and ourselves into one space. And then similarly about this idea that typically things at the moment work in a very linear, so people are kind of building an energy model, doing some carbon analysis, doing some cost analysis, and it's great all these tools today are kind of bringing all that, hopefully bringing people into a more kind of focus and awareness of that. So again, the idea is to kind of bring that together. And then the other thing we were frustrated by was this sense that on our projects we were kind of developing kind of knowledge and understanding from these projects, but we wanted a way of kind of very rapidly being able to bring that to bear on new projects. So the idea of Ecolab is you start from, as Joe was saying, you can start from just a kind of concept parametric idea of a building, or you can start from geometry, but you can apply templates to that concept. And those templates can be applied to very quickly populate its materials for embodied carbon, its energy performance and its cost. And then as you go through the process, those templates can be kind of saved and then applied to new projects. So we can kind of learn and refine things as we move through. So the tool itself, we've been working on this for a while. It was kind of established in 2013. It was originally Innovate funded project looking at kind of early stage design tools. Currently, we've also got a new Innovate grant. We're looking at kind of optimization elements of the tool. It's released as a commercial product, as a beta. There's a kind of very low cost version through to a kind of very premium version. We're very keen to kind of make it very affordable. And we're working towards a full commercial release in June 2021 with the kind of Innovate Optimizer tool coming out Q4 2021. It's cloud-based to enable it to be used by everybody together at the same time. And this diagram shows the kind of concept of this idea on the right, these templates for structures, systems, cost, distribution, carbon, all kind of flowing through back through the project into your kind of building. So all of this kind of knowledge, materials and libraries are all there and can be applied at the very early stage of the project to fully populate the geometry. And within the tool, you can look at a whole range of options, simulate them using, so the energy model is Energy Plus, there's a carbon model that's an embodied carbon, which is again kind of looking at stages A through to C, including use, and there's also a cost engine as well. And you can go in and interrogate your results of individual options or compare them within the tool, and you can kind of see the scatter graph on the left. So quite a few different people have been really interested in this. We've been working as architects using the tool, kind of providing consultancy service, kind of often right at the beginning of projects on this. And this is a very quick example of some of the work we've been doing. So this is looking at a whole life carbon study on an office building, kind of built in the 60s. Not too bad energy performance, but not brilliant. And we used Ecolab to kind of look at the relative performance. So this is where this whole idea, I think, of how important it is to sort of look at these things early on. So we were looking at the idea of, do the client retrofit it? Do they knock it down and build it again? And to what standard? And you can see actually that if they did knock it down and rebuild it, our modelling showed that actually after 60 years, it would actually be 17% worse than they just operated this building for the next 60 years as it was. Refurbishment to compliance with very slight improvements, but obviously you needed to move through to actually using passive house, looking at Enefit, and pursuing a low carbon kind of material agenda to achieve an actual carbon reduction in practice. When you look at this over time, it's even more profound. And we can see the kind of build up here on the left. But when you wind back in time, really very few options are outperforming business as usual by 2050. So you've actually put more carbon into the atmosphere if you've knocked the building down and rebuilt it, or even if you've refurbished to compliance by year 2050. So I think it just shows the kind of power this modelling can have in terms of guiding decision making, that we really need to avoid, we really need to guide people's decisions now, because we're baking in solutions for the long term, which are going to have big impacts on the climate. And as Joe was saying, we need to take action now to make changes in the future. And actually those need to be fairly radical, really. And I think these tools are starting to enable us to explain to clients how important these decisions are. If people are interested in Rapier, they can log on. Rapier.net is the website, and have a look. It's lots of information there. If people are interested, they can sign up, or feel free to email me if you'd like some further details.
Wonderful. In time. The buzz has not even gone. I like that. Those are great presentations. Thank you very much, James. Now I'd like to go over to Jake, please.
Brilliant. Thank you, Mark. So let me just share. Yeah, so I think there's some great presentations there, some great points, which I'm probably going to repeat slightly as well. But let's just kind of jump into it. Brilliant. Okay, so yeah, so just I'll take it back a little bit to the beginning for people. I think this the graphic on the right there comes off a website you can find, which is a map of all the different constituencies in the UK and local councils who have put climate plans in place. So that's really just to say, why are we doing this? And actually, what's interesting, the Northeast doesn't have quite as many as some of the other regions. But what you can see is actually the vast majority of the country, the councils have decided that they're going to reach some definition of zero carbon by 2030, which is actually within the lifetime of design projects that we have in the office. We know some projects take more than 10 years to complete. So really, this is just a thing to point out the urgency of this. We need to be doing this right now if we're going to do like a proper definition of zero carbon. So what's a proper definition of zero carbon? This is how we would explain it. There's a lot on this slide, but see at the bottom there, net zero whole life carbon. So we try and just simplify this right down for clients. We have three things: operational carbon, embodied carbon, and offsetting of various forms. And that's broken down. If you look at the top right there, they're the RICS, the British Standard, the RICS, and the RIBA guidance, which all follows these same protocols, and that's how it's broken down in that guidance. And just so you know, just in helpfully there, I think in yellow is what a lot of councils and for example, the zero carbon homes in London takes into account the yellow, but there's a lot of pink there, and I think that's a very useful kind of diagram we find with clients to encourage them to look at the kind of wider scope. So we like to describe this as kind of whole life design at Hawkins Brand, to go past just whole life carbon design and just the whole life. And also, it's just a little, it looks like an advert. It's not meant as an advert. It's more to say we work on a lot of different types of projects, and it can be very difficult to benchmark our projects. For example, the image on the right there is a swimming pool, which is one of the first projects that we ran through the tool. It's got a lot of CLT, but how do you benchmark a small swimming pool for a private school? It's an unusual type of building. It doesn't hit most of the kind of RIBA targets, and similarly for a lot of our other projects, laboratories and the like. So we like to give them we like to describe sustainability like this at Hawkins Brown, reducing carbon, but increasing society at the same time, because there's always there are trade-offs, like I said in the last talk. We can't just always be trying to go for the lowest whole life or embodied or operational carbon strategy. That's linked to all these other things, and sometimes there are conflicts in that. Longevity may mean that you build a more robust building which has a higher upfront embodied carbon cost, but it may be worth it depending on the type of building. Health, again, we're working on a lot of hospitals. Hospitals have a lot of requirements for embodied energy, but also embodied carbon to support some of the large MRI machines and this type of thing. So we ask our designers to really think of it as a kind of combined approach. And then the point that pretty much everyone has made, early impact is so important. It's so key. And just to give a brief example, I think everyone knows the planning process. Once you apply for planning, you've pretty much locked in your facade and your structure. Your facade and your structure on a typical building, typical low energy building, may account for something like 80% of the whole life carbon impact. So it's very, very important that we get that decided early on in the process. So that all led to the creation of the Hawkins Brown Emissions Reduction Toolkit, which is either described as HBERT or Herbert, depending on it's an ongoing kind of controversy that. And so, so what I'm mostly going to be talking about today is what we describe as Herbert version 1, which is a free open source tool. You can download it for free. You can download all the source code for free. It gives you complete access to the data, and I'll go into more detail that later on. But I'll just show a little preview as well where we've got to our in-house tool, which is called version 2, which has a whole kind of web interface. It's basically the same tool, works on the same data sets, but it has a lot more kind of analysis and comparison kind of tools. And then we have, based off that information, we've created a whole series of other tools which are kind of more similar to some of the things that Joe showed from FCB. And basically, and I think any practice can do this, is once you start collecting the data, you build up the knowledge about, for example, your standard build-ups that you like to use. We can put that then into our Revit models, and we have more standard build-ups, and then we can put that, when we have all those standard build-ups and we have enough analyses of whole buildings, we can put that into our spreadsheet models, and we can do whole master plans and whole urban designs, because we keep using that data. So generating these benchmarks is really important. And then this is how we do it in version 2. So there's a splash screen that sits in our Revit models. It gives our designers this same page on every single project, and it has very simple breakdown graph that's always the same breakdown of all the different elements, and trying to get them used to this one single number, which is the whole life carbon throughout per meter squared of building, and kilograms of carbon dioxide equivalent emissions per meter squared of gross internal area. It's a bit of a mouthful, but it's just one number, and we're really trying to get people used to it. And then we compare that on our web tool like this, and it allows a whole series of different graphical outputs and comparisons. I thought what I'd do actually is just show a little bit of the web tool just briefly, don't mind. So this is how it looks on the actual web. So let's go back completely. This is how it looks on the web when you go inside, and what we're doing really, and what I think is the real strength of these type of tools, and why actually, in my opinion, architects really need to get into working with this, is its detailed spec. It's the kind of detailed spec that only architects do, and only architects are able to kind of bring together all of these very different inputs into a whole building. So this is kind of what we have. These are our standard wall build-ups that we have now in Revit that we give to our teams. And there's a whole lot of learning gone into this. So there's U value, there's a fire retardance level, there's air tightness levels. We know a lot about these systems. We know what they can achieve, and we also then are able to create the right kind of Revit materials and elements so that they export an accurate impact of the total embodied carbon. Once we then have that, we have the components that builds up into projects. We load a load of projects up here, and then with the eventual aim of when they've fully gone all through the process, that we can have this leaderboard benchmarks, and we can see all projects in the office. As Joe was saying, competition and kind of comparative analysis I find to be a very useful kind of driver here. And actually, while there is industry guidance, the RIBA has published a series of targets from RIBA 2030 commitment. They are, when applying particularly to odd typologies like laboratory buildings, it can actually be a lot more useful to either compare to similar projects we've done in the past, or to benchmark against themselves. So, using iterative design and throughout the process. So, but that's our kind of in-house version of the tool. What I really wanted to encourage you to look at and tell you about today is the Herbert version 1, which is free. It's just quickly what it is. It works inside Revit, so you do need a Revit license, unfortunately, if you don't have that. Although any students on the call, you can get free Revit license if you're a student. You can download the tool here, hawkinsbrown.com/services/Herbert. If you just search for Herbert, you will find it on Google. And it has, when you go on that download page, it talks you through all the different things about the tool, and it talks you through what you also get when you download the tool. You'll get a how-to guide. It'll show some links to videos of how to use the tool. So I'm not going to go in too much depth about how to do that now. This is just, again, saying there it's version 1, but it has been updated to include the most recent versions of the embodied carbon factors from the ICE database. If you know about that, the inventory of carbon and energy, originally it was using version 2. Now it's been updated to version 3. So yeah, it's not just a tool that we've left behind. We are making continued improvements to that. And then this is again a different way of laying out the different life cycle stages of a project. And then if you look at the green and the black, this is just showing what the total scope of Herbert version 1 is at the moment, which is A1 to 5, B4, and C1 to 4. It does allow you. What I think is fantastic about this tool is that the way that it works, well, I'll get to that in a minute, but if you see here, this is how it looks in your actual Revit screen. And if you look at number 2 there, just in the background, that's a little clip of the of how we actually record the data, which is in custom schedules. And if anyone knows about using schedules in Revit, you'll know that you can export all that schedule data in several different formats, but in formats where you can basically just open it up in Excel. So what that allows you to do is it allows you to get access to basically all the raw data and modify it in any way you want. You can put on the extra factors for transport. You can modify the factors for any of the elements if you know better data, or you find the EPD data later on and you want to make it more accurate. You can do all that work in Excel if you'd rather, or optioneering in Excel, and then kind of bring it back into your Revit modeling if you prefer to work in that way. The tool basically, if you look at number 4 there, you get a little icon on your taskbar. This opens up this screen. You put in that's the extent. There's very little information that you're required to put in, and then it pings out the kind of image that you see behind in number 5. I'll show you in a bit more detail.
Well, we're on time, just so you know.
Yeah. So I realised that. So just very quickly. You can download, you can unzip it, go to this website, you get all the details there, you get exactly what you want. You get a whole set of 48 materials, fetch some material parameters, and that's recorded there as a kind of custom material, so you can see it on there. And you will get this very complex little data, but that spits it out for you in a nice, easy to read tree graph. Lots of people are using it. And yeah, we really just want to encourage review, reduce, report, and let's keep sharing information as an industry so that we can get to where we need to be on this.
Thank you very much, Jake. I like that review, reduce, report. I think that's a great summary there. Okay, so without any more to do, let's get over to Tim Martel, please.
The first thing to say is that the ACB tool does the whole life cycle. It goes from A to C, including the manufacturer, not only the A1 to A3 that's covered in the ICE database, but also A4, A5, the construction process, the in-use phases, including all of the additional emissions that are included in that, the replacements that are included, the end of life. It includes the complexity of the end of life, the complexity for timber emissions, sequestration, includes all of that, and also includes D as well. I'm going to launch straight into a quick demonstration of, there's 2 slightly different versions of it. One version is a standalone demo, a standalone version which is it's just a separate spreadsheet, and the other version can be used with the Passive House software PHPP. So this version, the ACB standalone version carbon calculator, is fairly straightforward. At this level, what you can see is a list of materials and the results for those materials. So you've got the results in terms of the manufacture, the storage, all these different stages, C1 to C3 and D, and they're coloured in terms of the worst is a redder colour and better is a greener colour. And this is a kind of a top level view that we're looking at here. You have 4 options where you can just change a material into a one option. If you're looking at option 1, well, all these materials are in option 1 at the moment, but you could have write a material for option 2 or 3 or 4. You can have 4 options. Most of these materials are by area, or you've then got windows, a separate area for windows, PV and other materials, and you've got the summary below. And in this case, there's also results that are fed into this table. This table's always there. It's just you enter data above to make sure that it fills out. It fills out automatically when you select a category in this thing here. So what I've just done there is I've flipped between a condensed view, which is a overall summary, and a more detailed view. So in the detailed view, you get the more information about the quantities, and the quantities are quite important, because if you select a material, say we add a material here, we can select, say, well, we can select a material that's appropriate for a particular location, like the intermediate floor, the roof covering, extra foundations. We can select something from there, or we can just show all, or we can just enter something. So if we entered brick, for example, then we would find one material like that. We can enter that in, and when it writes that, it gives you the units that it has to be measured in. In this case, it wants the information. This is because the embodied CO2 information is in these units, kilograms of CO2 per kilogram. So it needs you to enter kilograms for that. And that's easy because it's actually given you the formula and it's highlighted the cells you need to enter. So if we entered, say, 4 meters by 5 meters by, well, it'd be 103. It's used the, because it knew it was kilograms, it's multiplied by the density, which is a yellow cell. That means you can change it if you want to. If you happen to know it's a type of brick which is a different density, you can change that. You can change where it came from. If it's general national source, then you can choose that. It might be that it's local, or for some materials they might be from Europe or from worldwide. So you can change that. That changes the assumptions there. This is using standard RICS assumptions, and then you can change that if you have extra information. We've got similar dialogues for the other things, the windows and the PV. We've got similar dialogues which allow you to enter those. Similar dialogues for the other materials. You can add other things here. For example, we've got a boiler in there. What if you change that to an air source heat pump? You could select an air source heat pump there and write that. And then if I just press finish there, that's not now 1 kilowatts. Let's say that's a 5.6 kilowatt heat pump. So fairly straightforward to use. And one thing, let's see, we've heard a lot of other tools here today. So how does this differ? What is the same, and how does it differ from the other tools that we've seen? Well, some of the things that are the same, it uses ICE data from the ICE database, but here's where it differs actually. From the point of view of the data, the the ICE database only really covers A1 to A3. To get all the other phases, B and C, what you really need is to have more detailed information which covers those, and you can only get that from EPDs. There are a lot of EPDs out. This is entered about, well, let's see, somewhere between 200 and 300 of them. And so it contains all the materials in here. And the EPDs themselves contain a little bit of complexity these days. You have EPDs, and this is a specialism of the tool. It can handle that complexity of the section of the C, the end of life of the material. So within that, you could have various scenarios, the recycling, incineration, and landfill. And the way that the EPD covers that could be a number of different ways. It could be that it's missing, in which case the RICS provides guidelines of how to estimate that, so it does that. It could be that the EPD contains the exact same proportion of these which the national standards require. Well, I'm saying national standards, I mean the RICS guidelines require, or it could mean that it could be a 100% scenario EPD where it gives 100% of each type, and you have to choose exactly which one will fit. So it handles that too. And below here, I should say this does contain a graph at the bottom. And the graph, if we open everything up, there's a graph further down. There's the transport emissions assumptions there. There's also the assumptions about recycling straight from RICS. This has been professionally checked. We had someone who earns their living checking EPDs and writing the product classification, the rules, had it checked by them, and it's just finished and come out of that process. So let's just, there we are, there's the graph there. Oh. Sorry, it's a bit of a lag on my screen, but there we are, there's the graph. It's only because we've got, actually, it will create the text labels for it as well. Oh yeah, it takes a moment to do, but then the last thing I'm going to say is that there we are, there's the graph with the RIBA information about how you did on the RIBA challenge. And then the last thing I'll say is there is a version, the PHPP version also does that, but it takes the information from PHPP instead. There's where we can get it from. Thank you very much.
Thank you very much, Tim. Wonderful. So there we have 50 tools in just about 50 minutes. I think we managed to do that. Thank you very much to the presenters for that, because yeah, it's an incredible job just to keep on time. Never mind the content. So well done. Now, any questions? Let's go through the questions. We've had questions through, and Alice has been kindly collating them in the background. So what do we have? Taking it from the top, as it were. So well, let's just go to, if I can just skip through to, there are no, just so you know, James Todd, this is no specific questions relating to the Ecolab tool at the moment. Okay, so in terms of one of the initial questions about the iStructE tool, carbon tool, was that it seemed to be very kind of focused on structural engineering, and could it be used by architects? Could you fill us in on your thoughts on that, Penny, please?
Yeah, I mean, yeah, it's fair to say that it was a tool designed for structural engineers to use. But in terms of the way that the tool works, if someone wanted to develop it and include all of the architectural materials into it as standard, then yeah, it can definitely be quite easily adapted so that we can include all the architectural materials as well. In the short term, if someone wanted to pick it up and add in architectural materials like facade materials, for instance, or plasterboard and the like, plasterboard's actually already in there, then you can do so through the custom EPD table. I think you can add up to 15 different materials in there. So yeah, it could certainly be tweaked in the short term. I suppose longer term, if there was an architectural practice that wanted to partner with us to get it working from an architectural point of view, then yeah, we'd be open to talk about that for sure.
And then so you, across the board, a question really, though it was initially directed towards you again, Penny, was transport. How do you handle transport?
Can I share my screen quickly, because it might just be helpful to
yeah, sure.
Might just be helpful to show it, because obviously I had to gloss over a bit quick. So in terms of all of the material data, transportation is in there both for A4 and C2 for all of the standard data. But what I touched on very quickly was down here, if you want to calculate an A4 value, then you can simply say how far it's travelled by road, distance by sea, just put a number of kilometres in, and so on. So if you have got something that's being transported to site in a different way to what the standard EPD says, you can simply calculate the value there, and then either amend the material specification in here by updating this column, or add it as a separate custom EPD. So yeah, it is perfectly possible to do that.
Very good, thanks Penny. Now next question seems to jump here to Jake. I think the question was answered, but the question was asked nonetheless. Is it feasible to use Herbert for practices that don't use Revit?
Yeah, not particularly, to be honest. I mean, it was really designed for Revit, and that works into our workflows. So no, I would probably direct people towards the FCBS tool or something similar, a spreadsheet-based approach.
Yeah, no, that's very fair. But you can, of course, it is the one whereby using BIM software, you can measure and quantity, get all the quantities out, which can then be patched through to cells, which can then work with a range of different spreadsheet options. So
yes, but all the work we've had to do is actually to try and, because I mean, people that know BIM well will know that no one uses BIM for cost data because it's not accurate. It's not. Well, there's a lot I can go into about this, but effectively it works in layers. So if you think of it like BIM can calculate the volume of like a rainbow cake, but it can't do a Battenberg. It's the way I kind of think about it. Which is an issue, which is why we have all these custom materials and parameters that we have to create.
Yeah. Very good. Yeah, thanks for that clarification. So if anybody is looking to create their own version to work with their particular BIM tool that's not Revit, then keep that in mind. It works with layer cakes, but not Battenberg. And there was a question here from Adam Vaughan asking, where can the ACB standalone calculator be obtained? Well, I've put into the chat a range of different links that go through to the various different tools that we're talking about here. That I've pulled through from the different chats that have been taking place and the likes. But PHribbon.co.uk is one example for the ACB tool that Adam asked about. And incidentally, Tim, I notice, is doing a webinar tomorrow, and if you wanted to have a little bit more of a deeper look at the standalone version, then he'll be presenting that then. And I've put a link in the chat for that as well. Okay. There was one question that I did see crop up as well, which was relating to can these tools in general, I'll generalize, be used for extending buildings, not just kind of new builds, as it were? Is there any limitations? Does anybody perceive a reason why it might not work?
From my point of view, with the structural carbon tool, it can be used at any scale. So actually, when we launched this with the institution of structural engineers, one of the examples we gave was, say you're just taking one wall out in a building and putting a steel frame in, then you can use it at that level. You could just put a single beam in and you could calculate it. So yes, when you're looking at refurbs or extensions, then you can, if you're looking at refurb, then you can take the whole GIA of the whole development. So you'll always get a much lower embodied carbon than by square meter than if you were looking at a knockdown and rebuild. So yeah, there's absolutely no reason why we can't use our tool for that.
Yeah. Any other comments from any of the other presenters on this?
Yeah, Mark, I was just going to add in actually. Yeah, so within FCBS Carbon, you can as well. So there's a little drop down. You can model bits and you can say it's existing or new. So you can also capture how much retained embodied carbon. You know, how much you're sort of giving that kind of making that carbon work hard in future. So you just use the adjustment factor, which is just a kind of pro rata up and down. So if you know a percentage roughly of extra facade you're adding, you can add that in. It's not as easy, but we certainly do it on existing buildings all the time to sort of say, well, actually, you know, if you replace the facade, this is X amount, but you're saving this much. And it's a really powerful story. I think one of the presenters said, you know, about do you build in the first place? So yeah, that's a really good point.
Yeah, I know that PHribbon kind of started from a retrofit perspective, so I think the answer there will be, Tim could correct me, but I think the answer there will be that it will integrate very well.
Oh, it does. It does. It started from retrofit, but it's now for anything you like, really. So new build, retrofit, either. Yeah.
It's really good. I've not seen any further questions coming in at this particular point, so given that we've gone past the hour, I'd just like to say thank you very much to all of our presenters, and for the time that you've not only spent here right now, but also in preparing the presentations, because I know that always gets ignored from my experience. So thank you very much for a wonderful set of presentations and some great insight into what's going on with the tools that are currently available. And yeah, hats off. Because I haven't tried to write a spreadsheet from scratch to do all of this. I know how painful it is. So I thank you for having made these products available either for free or at a nominal cost at least. Thank you very much on behalf of the RIBA, the Sustainable Futures Forum in the North East. And yeah, I bid you fair adieu. Have a good day.
Thank you.